Question 14b. A firework is fired from the origin O on level ground with velocity 70 meters per second at an angle of inclination theta. The equations of motion of the firework are x equals 70t cos theta and y equals 70t sin theta minus 4.9t squared. Do not prove this. The firework explodes when it reaches its maximum height. Part 1. Show that the firework explodes at a height of 250 sine squared theta meters. The following are the marking guidelines for question 14b, part 1. For 1 mark, we have solves y dot equals 0 or equivalent merit, and for 2 marks, we have correct solution. The firework reaches the maximum height when the velocity in the vertical direction y dot is equal to 0. Now the displacement in the vertical direction is given by y equals 70t sine theta minus 4.9t squared. Differentiating this equation with respect to t to find the vertical velocity, we have y dot is equal to 70 sine theta minus 9.8t. Solving y dot equals 0 for time t to maximum height, we have 70 sine theta minus 9.8t equals 0. Rearranging this equation, we have 9.8t is equal to 70 sine theta. And finally, dividing both sides of this equation by 9.8, we get t is equal to 70 sine theta over 9.8. Now the maximum height is given by y of 70 sine theta over 9.8. And that equals 70 times 70 sine theta over 9.8 times sine theta minus 4.9 times 70 sine theta over 9.8 all squared. And that equals 500 sine squared theta minus 250 sine squared theta, which equals 250 sine squared theta as required. Part 2. Show that the firework explodes at a horizontal distance of 250 sine 2 theta meters from O. The horizontal displacement is given by x equals 70t cos theta, where t is equal to 70 sine theta over 9.8 from part 1. So substituting 70 sine theta over 9.8 for t into the horizontal displacement equation, we have x of 70 sine theta over 9.8 is equal to 70 times 70 sine theta over 9.8 times cos theta, and that equals 500 sine theta cos theta, which equals 250 times 2 sine theta cos theta, and by application of the double angle identity for sine, that is, 2 sine theta cos theta is equal to sine of 2 theta, that equals 250 sine 2 theta as required. Part 3. For best viewing, the firework must explode at a horizontal distance between 125 meters and 180 meters from O, and at least 150 meters above the ground. For what values of theta will this occur? The following are the marking guidelines for question 14b, part 3. For 1 mark, we have attempts to solve 250 sine 2 theta greater than 125 and less than 180, or 250 sine squared theta greater than 150 or equivalent merit. For 2 marks, we have obtained theta greater than 15 degrees and less than 23.05 degrees or equivalent merit, and for 3 marks, we have correct solution. The horizontal distance x of the firework needs to be greater than 125 meters and less than 180 meters for optimal viewing, where x is equal to 250 times sine of 2 theta, and this comes from part 2. So solving the two-way inequality, 250 times sine 2 theta greater than 125 and less than 180, dividing all terms by 250, we have sine 2 theta is greater than half and less than 18 over 25. Now the sine ratio is positive in quadrant 1 and quadrant 2, and we have positive ratios here, so this gives rise to 2 cases. Taking the inverse sine of all terms, we end up with 2 theta is greater than 30 degrees and less than 46.05448 and so on degrees. And then dividing all terms by 2, we have theta is greater than 15 degrees and less than 23.03 degrees corrected 2 decimal places. For the second case, we're considering quadrant 2 angles. That is, 2 theta is greater than 180 degrees minus 46.05 degrees, but less than 180 degrees minus 30 degrees. So 2 theta is greater than 133.945 degrees, but less than 150 degrees. Dividing all terms by 2, we end up with theta is greater than 66.97 degrees and less than 75 degrees. Now the next thing we need to test is the height of the firework, as it needs to be greater than or equal to 150 meters. So for case 1, the height of the firework when theta is equal to 15 degrees is given by the formula from part 1, which is 250 times sine squared 15 degrees, and that equals 16.7 meters. And when theta is equal to 23.03 degrees, that's 250 times sine squared of 23.03 degrees, and that equals 38.3 meters. And in both of these angles, they're both less than 150 meters, or result in a height less than 150 meters. So case 1 is incorrect. Now for case 2, we have theta is equal to 66.97 degrees. Substituting that into the formula from part 1 to get the height of the firework, that's 250 times sine squared 66.97 degrees, and that gives a height of 211.7 meters. And when theta is equal to 75 degrees, substituting this value of theta into the formula from part 1, 250 times sine squared of 75 degrees, and that equals 233.3 meters, which are both greater than or equal to 150 meters. Therefore, the values of theta where the firework explodes for best viewing are theta greater than 66.97 degrees or less than 75 degrees. The following is the feedback from the Marking Centre for question 14b. For part 1, in many responses, candidates recognise that maximum height occurred when y' equals 0. They worked out a value for t and substituted the value for t into the parametric equation for y to find the maximum height. In a number of responses, candidates unnecessarily found the second derivative and justified that their t value was a maximum. In some weaker responses, candidates incorrectly differentiated the vertical displacement as 70 cos theta minus 9.8 t. A large number of candidates found the Cartesian equation first. These candidates often found the maximum height after inadvertently answering part 2, with some not noticing this and reworking their solution in part 2, sometimes with different reasoning. In some responses, candidates incorrectly differentiated the Cartesian equation by confusing variables and constants. Candidates who used the Cartesian approach were generally less successful, as were candidates who first found where the projectile hit the ground. In a smaller number of responses, candidates simply quoted a formula for the maximum height and did not show the result. Others merely applied physics formulae. A number of candidates derived the equations of motion despite having been given these. In some weaker responses, candidates took a rote approach to problem solving. A small number of attempts also included inappropriate approximations for g or t. For part 2, most candidates who correctly answered part 1 completed this part easily. In some weaker responses, candidates simply quoted a formula for the maximum range and did not satisfactorily establish their result. For part 3, few candidates gained full marks on this part, but many made some progress by attempting to solve the inequalities 250 sine 2 theta greater than 125 and less than 180, and 250 sine squared theta greater than or equal to 150. In better responses, candidates found possible values for theta which satisfied one of the conditions for best viewing. In very few responses, candidates found the range of values that satisfied both inequalities. Generally speaking, Those who solved the inequality 250 sine squared theta greater than or equal to 150 directly by taking the square root of both sides were much more successful than those who changed sine squared theta to half times 1 minus cos 2 theta. A number of responses were marred by solving equations rather than inequalities. In a large number of weaker responses, candidates unsuccessfully tried to solve this problem using a Cartesian approach, and after pages of working still had not understood that the restrictions were on the maximum height and the corresponding horizontal distance. Candidates are reminded to look for links between question parts. Other candidates attempted to solve 70t cos theta greater than 125 but less than 180 and 70t sine theta minus 4.9t squared greater than or equal to 150. Again, ignoring the results of part 1 and 2. In many responses, candidates did not consider the domain of theta and or 2 theta, and it was exceedingly rare for any candidate to consider graphs of 250 sine 2 theta or 250 sine squared theta. In weaker responses, candidates often reversed inequality signs or wrote an angle of 0.40 radians as 0.40 pi radians.